All right, this is the problems that were asked in the email. So let's look through them. So we had 2G, which is a volume conversion problem. Remember, that means cubic. That means whatever they give us here, we're going to have to use this 3 times to get rid of the cubic inches. So we're starting with that 300 cubic inches. That's what we're starting with for the volume. So think about that as inches cubed, and they want us to convert it to cubic centimeters. So that's centimeters cubed. Well, you can put the inch that they gave you and the centimeter to make sure we cancel out a unit, but that's only going to cancel this out and make it a squared. So we'll have to do it another time and another time. So we'll need to do our conversion factor 3 times to get all 3 inches to cancel out with that. So I'm going to put these numbers in. So it was 1 inch equals 2.54 centimeters. We're essentially repeating that conversion 3 times because these are singular unit conversions, whereas our thing is a volume, which is cubed. Okay. So then we're going to get centimeters times centimeters times centimeters. So that'll be centimeters cubed. Let me get my calculator. And we're doing all the numbers are on top over 1. So this is going to be 300 times 2.54 times 2.54 times 2.54. And we're rounding to the nearest hundredth. So that's, remember, 2 decimal places. So 4916.1, and that 9 will bump that up to a 2. So this is going to equal 4916.12, and this would be centimeters cubed. But remember, you won't put the unit usually in the Newton, you'll just type in the number. Okay. So that's 2G. Let's move on to the next one. Number 8. It says Ben biked 14.6 kilometers, convert this distance to miles, round to the nearest tenth of a mile. So this one's in here just to remind you that if you don't see a conversion listed in Newton, so if you don't see one, like they don't say use something like this, so you don't see any of that information, that's a time to go look at our formula sheet. So we're looking for a way to convert kilometers to miles. So if you look on our front page of our formula sheet, we have this right here. 1 mile is about 1.6093 kilometers. Okay. So since we have this fact on our formula sheet and we do not have a fact given to us in the directions, that's what I'm going to use. So I'm going to write that down on that. So I'm just writing it on the top here. So 1 mile, I think I'm saying that right. Let me double check, is 1.6093 approximately. Now, sometimes you'll see it written in the directions, like they might say use 1.61. So that's why if Newton says use 1.61 kilometers equals 1 miles, if they put that in the directions, you need to follow those directions, but they didn't. So we used our formula sheet. So this is 14.6 kilometers. And to get kilometers canceled, we have to put kilometers on the bottom and miles on the top. And we put the 1 with the miles and the 1.6093 with the kilometers. Notice our kilometers will cancel out. And this one is division because your 14.6 is on top, but the next number is on bottom. That's not a 1. So we're going to divide by 1.6093, round to the nearest tenth. So this will be 9.1 miles. So 14.6 kilometers is about 9.1 miles if you ran it. All right. Charlie purchased 35 liters of gas in Canada. How many gallons did she purchase? Okay, so we're looking for gallons as our final answer, round to the nearest tenth. We do have facts on our formula sheet, but because we were given facts in the directions, we're going to use these. So we start with what we know, which was 35 liters over 1. And I see a conversion between liters and quarts. So I can put liter on the bottom so it'll cancel, quart on the top. And this was 0.95 liters is 1 quart. So now we've got out of liters, we're in quarts. And I have a relationship to get from quarts to gallons. So quarts needs to go in the bottom to make sure this unit cancels. Gallon will need to go on top. And remember, put your numbers next to their correct units. So 4 goes in the bottom, 1 goes on top. So we're going to be doing 35. And then the next number that's not a 1 is on the bottom. So we'll divide by 0.95. You can go ahead and hit enter if you want, just don't clear it. And then the next step is again on the bottom. So we'll divide again by 4. And so we're going to round to the nearest tenth. So this would be 9.2 gallons. Okay. So there's 8 and 9. Number 14, this one has to do with the finance section, but notice that they're not requiring you to do any Excel. They've already told you the PMT. The PMT, they did off like line. They did it for you. The monthly payment is going to be $550.84. Okay, so let's just read it. It says, you are considering 110,000 mortgage for 30 years with a 4.4% interest rate. So all of this information gives you how they got this in Excel, okay? But they already did it for you. You're only going to make the minimum payment each month. What is the total amount paid on the loan? Okay, so that would be if I make my minimum monthly payment, $550.84, because they want to know how much are we going to pay for this house total, because we're going to pay them back. Remember, this is interest and principal. And we're going to make that payment 12 times a year because that's how mortgages are paid for 30 years. So this is the total number of deposits essentially you're going to make to the bank to pay that loan off. So that would be 550.84 times 12 times 30. That's 198,302. Was it 0.4? Let me double check. Yeah, so 0.40. We want to write it in change. Usually we have two decimal places. Okay, so that's how much you're going to pay in total to the bank. Now, the house costs 110. So the difference between what we paid the bank and what the house actually cost, what we bought the house for, that would be how much interest that the bank collected. So the interest when you're doing a big loan like this is the amount paid, the total amount paid, what we just found out, minus the mortgage or whatever it is we borrowed, okay? Minus what we borrowed. So that's going to be 198,302.40 minus the 110,000. And so I'll take my calculator and subtract that off. That's going to be $88,302.40. So 88,302. So we almost paid for the house twice if you think about it like that. So over that 30-year time, yes, we bought that $110,000 house, but we paid $88,000 in interest. So you almost paid for the house twice. Okay. Okay, and then number 18. This one's just a standard Z-score question with us filling in some information after we find the Z-score. So it says IQ scores have an average, this is our mean, of 100 with a standard deviation of 16. If they're normal, what would we say is a Z-score for a score of 118? So this is a specific person's score, not the whole group's average, okay? So the Z-score formula says you take that specific person or that item in question, you subtract the average from it, and you always divide by the standard deviation. So that's the formula on your formula sheet for Z-score. So this is going to be 18 over 16. And since they didn't tell us to round, I believe they go ahead and just leave that to 3 decimal places on this one. If you look at the answer key. So 18 divided by 16. So just check your rounding rules is 1.125. Now, what does that mean? That means, remember, if you're on the bell curve and you standardize it so that 0 is the mean, and we have 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, -1, -2, -3. This is when we take raw data and turn it onto a Z position bell curve, essentially. This tells you how many standard deviations you are away from the mean. That's what the Z-score tells you. It tells you your position. So if you think about it, if I draw where that is, kind of right here, okay? I'm about 1.125 standard deviations, and I'm above the mean here because it's a positive Z-score. If I'd gotten negative 1.125, I would have been below the mean, okay? So you're just going to tell us the standard deviation is the value of the Z-score, regardless of the sign. You just tell us the value. So it's a 1.125. The negative or positive that you got when you did your formula, that has to do with it being above or below. So since this is positive, we're going to choose above, okay? So this is just the value of the number. This is the positive or negative, okay? Now, what they're saying here in this last part is they're asking you, they're saying, and you have to read the problem to know how to answer this. They say it's unusual if you're more than 3 standard deviations away from the mean, okay? So if you think about it, 3 standard deviations is 3 below to 3 above. Notice my blue mark is in that range. So it's not going to be an unusual value. It's actually what they said, you know, an IQ score of 118, I would say is not unusual because it's within -3 to 3, because the Z-score is not more than 3 standard deviations. And this is, again, just referencing back to the sign. So you choose above if it's a positive, which ours was, or you would choose below if it was a negative, okay? So we are not more than 3 standard deviations away from the mean. So we are not an atypical or unusual value. Okay. This would be considered a normal kind of place to be on the bell curve. It's when you're in those little tails on the end that it's kind of unusual. Okay. I hope this helps.